Um, just a quick announcement. I posted some more internships. It's certainly getting late in the summer internship season, but there are still internships out there. Also, we're seeing, I think, more entry-level jobs being posted here. So I'm trying to post some of those that I see, or when I see them. It's sometimes hard to find entry-level jobs, in the searching here. Just a couple notes. Some of these are for other places. What often happens is I'm doing a search like with LinkedIn or Google, and I find a posting for a position here, like Westinghouse will have a software engineering internship posted for Minnesota. So I'll go there and then while I'm there, I'll also see that they have other internships. So I'll just grab those. So I'm not actually searching. If you're interested in working somewhere else, I would certainly do some searching either with Google Jobs or LinkedIn on a specific location. Uh, when I'm looking at a Minnesota one or Wisconsin one, and then there are other ones at that same company there, I include those here also for that. So also again, not much in Duluth right now. The SAPI one is this desktop support intern. I'm not sure. They posted this, I think, a couple of months ago. Uh, and I know they were just interviewing candidates, or at least one of our students for a similar position, but they just posted this new. And so I don't know if this is a new position or a repost of a previous position or what, but it is a new posting on the SAPI website. So I think it might be a different position than what they originally posted. I'm not sure. But again, if you're looking for work in Duluth, this might be a good option here. So, um, okay, what are we going to do today, you ask? So we're going to do a little bit different thing today. We're going to we've been talking about these computational theory, Turing machines, and how you can use Turing machines to show that there are some limits to computation, some limits to what a computer can do. Uh, there, and we talked about the halting problem and showing that we can't make a Turing machine that can determine if another program, if all a generic Turing machine that can look at any program and any input and just tell if that program will halt or not. And then that relates to we can tie that into a number of other related kind of issues where we can't have a computer look at programs and make some declarations about them here. And that kind of gets us into a lot of this philosophical debate. We see this a lot in math also. And then again, these Turing theory ties into a lot of math theory where you're kind of asking what is the limits of human knowledge. The original idea, again, about 100 years ago, was that we were going to be able to prove everything, have a nice structured system from the ground up using first order logic and basically, build a nice framework for understanding the world with, logic and math. And we ran into some difficulties for that. So since then, there's always been this discussion on what is the limits of computing and intelligence. So we're going to have a little discussion on that. We're going to do learning activity 12 here. And what that is 6 questions, just nice, simple questions like, what are the limits of human knowledge? What is intelligence? Is the brain a computer? What about consciousness? Those sorts of light questions here. So for each question, and again, you're going to be broken up into teams of 3 here. And since there are 4 people in class here, we're going to do start with teams of 2 in class. You can get a start on all of this stuff here. Have you guys, I've been trying to do this randomly. Have you guys, do you care? I mean, have I been doing it randomly? You keep getting the same people. I mean, there's only four of you, so it doesn't really matter that much. So, okay. Um, so we'll try this out here. Let's see. Let's just see what last week was. Uh, so yeah, what the week before? Right. Okay. Addison hasn't worked with Jeffrey, in a while, a couple weeks. So, okay, we'll try that. Um, so, and then online students, we're going to assign you to in pairs of three, in teams of three to look at this. So again, you'll create this, share it with your team. So whoever gets started first can be student number one. Share this document with the team here. And again, you are going to, and so each student will be student one, two, or three. So like topic one, we want to do is student one type in their opinion. Read this topic here. Read, and again, there's a number of bullet points that just kind of help frame, the topic a little bit more and prompt you. You don't have to address all the bullet points. They're just thinking, things to prompt your thoughts there. Kind of expand what I was kind of meaning with this topic there. And then you want to express your opinion. I'd like to see a thoughtful response with clear arguments, detailed explanation. So not just a couple sentences, but a longer thing. I'm fine with you, spending some time thinking about this, looking at it, and then using resources, doing a little reading about it. Certainly, if you want to ask AI about it, especially if you're looking for some supporting arguments or ways to frame your position here. So certainly so in this topic one, student one lays out their opinion of it. And when that's done, student two will have their reaction to that and post their reaction to that. And then when they're done, well, at any time, student three will also have their reaction. And if student one and two are done, student three can react to all of them. Or if they're not, if just student one has an opinion, student three can react to that. So this is the reaction. So again, we need student one to have their opinion in here, and then student two and three post the reaction. And once we get at least one student's opinion and one student's reaction there, we want the first student to reflect on it and read the reaction stuff and see, do the reactions, do the other students' positions or arguments change or alter your point of view? Do you agree with them? What is your feeling on? So that's this reflection here. And the first topic, student one is there. The next student, topic two, student two does the initial opinion there. And the third topic, student three does the initial one. And whoever does the initial opinion also does the reflection when you are done here. And then we repeat topic four is back to student one, does the initial opinion and the reflection, and topic five, student two, initial opinion, reflection, and topic three here. So what I think we'll do in class here is let you work on this initially. So you can both post an opinion. So you'll be teams of two, so you can both post an opinion of one of these and a reaction on one of these stuff. And then I think we'll just, once you get that done for the first topics here, we'll just sit down and kind of share this because I'm kind of interested to hear. So we'll start you typing and put your positions in writing, and then we'll share these in a little while. Sound good? Okay. Online students, again, that's the idea. And so this is due on Sunday online, if you're not here. And so if by Sunday morning, you've student one hasn't, or student two hasn't posted their opinion here, and so you don't have anything to react to, you can just post your opinion instead here. So if you wait, if if the student opinions aren't there, you can wait, but by Sunday you can just convert the reaction to an opinion piece if your teammates are not contributing to this. Okay, so let's see how that's going to go. I'll let you start on this. Questions? Okay, I'll you get started on this. So again, make a copy of this, share it with your team, normal sort of stuff. Okay, we're wrapping up here, online students. So we've assigned teams. So we've had some people in class. We've assigned some of them, people who aren't in class, to finish off their teams. And the asynchronous, we have 3 asynchronous teams here that you can work with. So again, anyone on the team should just jump off and go in here, be student one, possibly, and then share this with the other people and work on it. By Sunday, we want all this done here, each student's opinions and reactions, and then a reflection from whoever was the initial student for the opinions. And just a note on the assignment for this week, I wanted to do more with proofs, but again, this isn't a math class. I know some of you don't have that much experience with proofs and writing proofs and doing that sort of proof. So what I decided to do to add a little flexibility here is look at AI generating proofs there. So I give you a problem, like there's 2 problems. One is, can we create and prove that a Turing machine can figure out palindromes with this sort of stuff? And the other one is just, can we create a Turing machine that can look at other Turing machines and see and analyze and say, does that Turing machine accept ABBA as our input there? I'm sorry, I grew up in the 70s, so anytime I do this sort of stuff, I have to work ABBA somewhere into this stuff. Plus, I think it's one of my wife's favorite songs. It wasn't until that movie came out, but that's good. Okay, so you're going to construct a proof, but rather than constructing the proof, we're going to have you use AI models. So I want you to first use a basic AI model to try to generate this proof, and then use one of the more advanced AI models. Sometimes they're called thinking or reasoning models or something like that. There are different ones available in different places. So like if I go to ChatGPT or DeepThink or whatever, I can often switch the auto or turn on thinking or something like that. And so like there's a research preview of ChatGPT 4.5, or there's these reasoning ones, some of those. So use a more advanced model and then answer these questions. So again, you don't have to come up with the proofs. You're going to have the AI come up with some proofs and then work through these proofs, compare them, and analyze the results for those proofs there. Again, if you are looking to go to grad school, you'll probably in grad school have to take a computational theory course, and in that point you'd be coming up with writing proofs like that. So if that's the case, you might want to look at this again. But again, if you're not going to grad school, you're not going to be coming up with need to come up with these proofs on your own, and so that's why we're kind of using AI as a supplement for this. So. Okay, so that's the assignment. Questions on that? All right, see you next week.